undefined?
8.
8. Okay, very good. Okay, so here we have 9 over 9 minus 7. I'm going to change it to x so it's easier for me to write. Okay, which value of x will make this expression undefined? We don't have to guess. We have 9 minus 7x cannot be 0. Negative 7x equals not equal negative 9, so x equals 9 over 7. So x cannot be 9 over 7 because 9 over 7 will make this expression undefined. You can ask me to evaluate it for anything else, but if you ask me to evaluate it for 9 over 7, I'll say sorry. Nice try.
Can you explain how you got that one more time?
I move 9 to the other side. I change its sign, and I divided both sides by negative 7.
Okay.
The denominator cannot be 0. Okay? Good. That's a good one. 4x over x squared minus 9. In this case, we have to completely factor the denominator. We cannot identify the values of x that make this expression undefined before we factor the denominator. And we studied factoring extensively. So how do we factor the denominator?
X plus 9, x minus.
You mean 3?
Yes, that's what I meant.
Good. Very good. So then x cannot be. What are the values that x can never take? If you ask me, evaluate this for these values, I'll say sorry.
Negative 3 and 3.
Yes, positive and negative 3. These values make the expression undefined. Good. Give 2 examples of rational expression. Each of these include values of x. Okay. Okay. Good. Now, before we start this example, I would like to go back to the first problem that we skipped. So this is 15. So we come back. Now I want to go back to, okay. So drag the correct ending from the above list into the area below to complete each statement. To simplify rational expressions, interchange the numerator and the denominator. No, multiply numerators and multiply denominators. What is going on? Multiply by its reciprocal. Remove a factor equal to 1.
I think it was that one.
I'm sorry?
I think it's that one it wants.
Yeah, but it makes no sense. This is not a rule to remove a factor of equal to 1 to simplify rational expressions. This is not a rule by any means. To multiply rational expressions, yeah, we have to multiply the numerators and multiply the denominators. We know this because that's how we multiply fractions in general. To find the reciprocal, that's correct. We interchange the numerator and the denominator. That's correct. That's the reciprocal. To divide the rational expression, we multiply by its reciprocal. That's correct. But this makes no sense, number 1. Remove a factor equal to 1. That's not. Okay. Yes, that's fine. Okay. So x minus 9 divided by 9 minus x. Perfect. So first things first. The numerator is nice and neat, but the denominator is not, because it's not in descending order. So first I have to do this. Then there is something I don't like about the denominator, and this is one of the factoring strategy. Descending order, greatest common factor, negative leading coefficient. So I have to factor out negative 1. Then what is left in parentheses after we factor out negative 1?
X minus 9.
X minus 9. Do not touch anything. Do not touch anything, don't do anything. The first thing we have to write is the restriction on x. X cannot equal
9.
exactly. Only now you are allowed to simplify factors. We are allowed to simplify factors. X minus 9 divided by x minus 9 is 1. X minus 9 divided by x minus 9 is 1. And now what is left in the numerator is this. What is left in the denominator is this, including the sign. So the answer is negative 1. But the correct answer, I don't care what they say. The correct answer is not negative 1. The correct answer is negative 1 if x is never equal to 9. That's the correct answer. See, we talked about this some time ago. 2 over 2 is indeed 1, and I don't have to write the 2 not equal to 0. Of course 2 is not 0. But x divided by x is 1 only if x is not 0. This is the correct answer. Because if x is 0, 0 over 0 is not 1. And it's not called undefined either. It's indeterminate, no matter what they say. So the simplified form of this expression is negative 1 only if x is not equal to 9. If x equals 9, the expression is indeterminate. Okay. Good. So we know how to evaluate rational expressions. Now we are simplifying rational expressions. 6x plus 24, everything divided by x squared minus 16. Good. We have to completely factor the numerator and the denominator. Can anyone factor the numerator for us? That's why we studied factoring. This is the second application of factoring. The first one is solving equations. The second one is simplifying, multiplying, etc., simplifying rational expressions and anything else that can be simplified.
Factor out 6
Indeed. What is left in parentheses?
plus 4.
X plus 4 indeed. And now we have to factor completely the denominator.
X plus 4. X minus 4.
Very good. We don't touch anything before we state restrictions on x. Do not simplify, do not touch anything before you state the restrictions on x.
X cannot be 4 or negative 4.
Good. And now, what common factor from the top and the bottom we can simplify?
X plus 4.
X plus 4 is a common factor. So the simplify.
Paper.
I'm sorry? Oh, yeah. Sorry.
Okay, thank you.
Sorry about that. 6 divided by x minus 4. The correct answer is this. The simplified form is indeed 6 over x minus 4. As long as x is never plus or minus 4. If it is either one, the expression does not exist or it's undefined. So it's indeterminate. Any questions? Okay, moving on. X plus 2 over x squared minus 5x minus 14. X squared minus 5x minus 14. Good, so let's work on this for 1 minute. 1 minute. Let's see what we get. Remember to state restrictions on x, even if the book does not require those. Please keep that in your mind. Restrictions on x have to be stated before we simplify, not after we simplify. When you have the factor form in the denominator, let me know.
like 7 and 2.
So the denominator is x minus 7 and x plus 2. I have to state that x cannot equal 7 and x cannot equal negative 2. I cannot continue before I state the restrictions. And now I'm allowed to simplify, and I do get 1 over x minus 7 only if x does not equal 7 and x does not equal negative 2. Is that clear?
Yes,
You understand why?
because if 7, if it was 7, it would be 0, or undetermined.
Exactly.
And I'm not sure why negative 2.
I'm sorry?
I'm not sure why it why negative 2 would work, but I
Because
understand stuff.
it will be 0 over 0 over 0.
Oh, yeah, okay.
But
makes sense.
it doesn't matter what's in the numerator. Both restrictions have to be fulfilled because 0 in the denominator is not acceptable.
Okay.
Is that okay?
Yes.
Okay, moving on to the next problem. Where are you guys? Okay, I see you now. Good. Good. Okay, so let's work on the next one. We're still simplifying. We haven't gotten to multiplying and dividing rational expressions yet. So we have y squared minus 5y plus 4. Everything divided by y squared minus y minus 12. Of course, we have to completely factor the numerator and the denominator before we do anything else. So let's work on this for 1 minute. So we cannot do anything before we completely don't try to simplify y squared with y squared, or do not try anything we did not do in class. So I just want to draw your attention to something. One student on the previous test on y cubed plus 8 said this: y plus 2 to the third. Have we ever talked about y plus 2 to the third? So please, as I'm saying again, do not try to invent anything. At this level, at our level, we can no longer invent. We have to just do what we are taught to do or taught to do, okay? So as you know, this will have 4 terms. We discussed this. A binomial squared has 3 terms. A binomial cubed has 4 terms. So here there are 2 terms, and here there are 4. You cannot set equal 2 terms to 4 terms or say that they are the same. So we have to completely factor the numerator, completely factor the denominator, state 2 restrictions, one coming from here and one coming from here, and then simplify. We never state restrictions for the numerator. We only state restrictions for the denominator. Good. So how do you factor the top?
Minus 4 plus 1.
Y minus 1, y minus 4. And how do we factor the denominator?
Minus 4 plus 3.
Y minus 4, y plus 3. Now you need to give me 2 restrictions. One from here. We don't care about the numerator. We don't state restrictions on the numerator. The numerator is free to be whatever. The restrictions are only for the denominator.
4 negative.
4 and negative 3. Now we are allowed to simplify because we simplify only factors. And the only factor that we can simplify is y minus 4. So the simplified form is not y minus 1 over y plus 3. Is y minus 1 over y plus 3 if these conditions are fulfilled. Otherwise, the whole thing collapses. I think we got the idea on simplification. We can come back to other examples if you want, but I like to get to multiplying and dividing. And then we'll come back. This is still multiplication, simplification, sorry. Yes, I would like us to multiply to rational expressions. Okay, here it is. So multiplication. So for now, what have we looked at? Evaluating and simplification. Now we want to multiply. X squared plus x divided by x squared minus 8x plus 7 multiplied by x minus 7 over x squared minus 1. As I mentioned before, we do not multiply before we simplify. Ever, ever, ever. If it's not possible to simplify, it's a different story. So we look at the first fraction and we know that we can factor something in the numerator and we can factor the denominator. What can we factor out in the numerator? Yes. And what is left in parentheses?
X plus minus X.
It's not possible. I started with 2 terms. Oh, no. If I start with 2 terms, I have to have 2 terms in parentheses. Otherwise, I will never recover the starting point.
X plus 1.
Indeed. What do we factor or how do we handle the denominator?
Minus 7 minus 1.
X minus 7 and x minus 1. Perfect. Now we move on. The numerator of x minus 7 stays. It's a linear factor. We cannot simplify that. We cannot factor that. This is it. But we have to look at the denominator, which is x squared minus 1. So we know how to factor this because we know special products.
X plus 1, x minus 1.
Do not touch anything. Do not do anything. Give me the restrictions, please. For this fraction to exist and this fraction to exist.
7 and 1
And negative 1.
and 8.
Yes, the restrictions have to be stated. Now I can do whatever I want. Of course, within limits, meaning I can only simplify factors. And I'll simplify a factor of x plus 1 with a factor of x plus 1. Please write 1 so you don't think, oh, it's 0, I have to multiply by 0. I've seen that. And of course, I will simplify a factor of x minus 7 with a factor of x minus 7. Can anyone give us the final form, including the restrictions?
X over x minus 1 squared.
That's it. So the simplified form of this product of 2 rational expressions is x over x minus 1 squared only under the condition that x is never 7 or plus or minus 1. Any questions on this problem? Okay, let's continue working on products. Okay, I want one more product before we look at division. Okay, so let's look at this one. Let's work on this one for a minute. X plus 2 times x minus 9 over x squared minus 7x minus 18. So let's work on this for 1 minute, and then we move on to division of rational expressions. Remember, x plus 2 is basically x plus 2 over 1, not 1 over x plus 2. Never. It's like I'm saying I have $2 in my pocket. No, actually I have 1/2. Good. Remember, restrictions are stated on expressions before simplification. So we do have x plus 2 over 1 times x minus 9. These are linear factors. You cannot do anything to them. But I have to I have to factor the denominator.
X minus 9, x plus 2.
X minus 9 and x plus 2. I have to state two restrictions, and then I am free to simplify, not before.
9 and negative 2.
9 and negative 2. And now I can simplify. Please write 1 so you don't think it's 0. X plus 2 divided by x plus 2, x plus 2 divided by x plus 2, x minus 9 divided by x minus 9, x minus 9 divided by x minus 9. What is the simplified form of this expression, of this product?
1.
1, assuming that the conditions are fulfilled. Perfect. Okay, now let's look at division of rational expressions. Same thing as dividing fractions.